Hi, this is Mr. Wakefield here, and what we're going to be talking about right now is adding and subtracting terms and polynomials. Let's start out with terms. Term is just a simple way of saying the official name for a term, which is monomial. There's different types of terms in math, but unless I say otherwise, whenever I say the word term, I'm referring to a monomial. So let's learn about what a monomial is. The easiest way to define it is to give you some examples instead of giving you the definition we have down here, which you're welcome to read as well. Let's look at some examples. So if you have just a normal constant number, and when I say constant, I mean like a number that you actually know, like 5 or -6, okay, as opposed to a variable like x or y, okay. Because 5 will always be 5. It will constantly be 5. It will never change, so we call it a constant. Same thing with -6. So if you've got a constant like 5, that's a monomial. But if you have a constant like -6 and it's being multiplied by a variable with a whole number power, I'll say that one more time. Okay, if you have a constant number and it's being multiplied, it has to be multiplied, okay, times a variable with a whole number exponent. What I mean by whole number is 0, 1, 2, 3, 4, one of those numbers. Okay, so 2, 4, 3, those are all the type of exponents that are whole number exponents. So if you have a constant number times a variable to a whole number power, that's also a monomial or a term. Okay, we usually call it a term. You could also have one more variable. See how here we have the same thing as the previous term up here, where you have a constant number 8 times, again it has to be multiplication, a variable to a whole number power. But the difference is that now we have another variable. That's okay as long as it's also being multiplied right here, which you can see that it is, times a variable to another whole number power 3. So that's a monomial as well. This also is a monomial down here, 10, a constant number, times x. Now you might be wondering, wait a second, where's the exponent? Well, when the exponent is invisible, that means that the exponent is 1. So when you see x, that's the same thing as x to the first power. Okay, so, and 1 is a whole number exponent, so that's fine. So this is also a term. So let's talk about a couple of things here when we talk about terms or monomials. Okay, first of all, we have this thing called coefficients, which we talk about a lot, so let's make sure we understand what that is. Okay, the coefficients usually in the beginning of the term, and it usually is, in fact it always is, the constant number that is being multiplied by the variable parts of the term. Okay, now in this first term there are no variables, and so when that happens, if you just have a constant number, then the coefficient is just that same number, 5. But if you have a constant number times a variable to its whole number power, then the coefficient will just be that constant number that, again, usually is in the front of the term being multiplied by the variable. Same thing here. 8 is being multiplied by the variable parts of the term. And so 8 is, because it's the constant number, it is the going to be the coefficient. Same thing here. 10 times the variable part of the term. So 10 is that constant number that's being multiplied by the variable part, so that's the coefficient as well. One other thing we need to talk about is this thing called degrees. Okay, a degree in a term is going to be the exponent. So let's look at the second one as an example here. I'll get back to 5 here in a minute. The exponent there is 2, right? So the degree of that term is going to be 2. So what happens when you have no variable? When you have no variable, the degree is 0 because there's no variable there. Okay, there's other reasons too, but that's the one reason you can that is easy to understand. So no variable, degree is 0. When you have two variables, what you do is you add up the exponents for the purpose of figuring out the degree. Don't put a 7 inside the term itself. Just when you're figuring out the degree, you add up the exponents if there's more than one variable. And so 7, 4 plus 3. Here, as we already mentioned, the exponent is 1. It is 1 even though it's invisible, so we do need to say 1. You see the difference here? Okay, this one, you can't see the exponent, but you know that it's x to the first, so that's why it's 1. Up here, there is no variable at all, and so that's why this is a different degree at 0. Okay, so let's try that out down here with what we call a polynomial. Okay, let's talk about a polynomial here. A polynomial, you'll see here that we have 4 terms. Okay, 4 terms. Excuse me. So why do I say that? Why do I say that there's 4 terms? It's because terms in a polynomial, poly means many usually. In this case, it means 1 or more. Okay, it's just like a monomial, okay, where mono means 1. Okay, poly means 1 or more. And what it means is it means that you have 1 or more terms that are being added or subtracted together. Okay, see these minuses and pluses right here? Okay, when you have a polynomial, what a polynomial is it consists of 1 or more terms being added and subtracted together, like I said. But if you have more than 1, they are separated. Those terms are separated by minuses and pluses. Since you have these 3 minuses and pluses combined here, that makes a total of 4 terms because they separated into 4 terms right there. And so that's what a polynomial is all about. All right. So like if you look at this one right here, this is just part of a bigger problem, which we'll talk about in a little bit. But just look into the thing I underlined. See how you have 3 terms right there. Okay. And I know it's 3 because the minus and plus separates those 3 terms. Okay, so that when somebody asks you, hey, how many terms does this polynomial have right here? It is going to be 3 because of the minus and plus. And you know this is a polynomial because all 3 of these things that are separated by the minus and plus, all 3 of them fit the description of terms that I just defined at the top of the page. Okay, so that's definitely a polynomial. Okay. So now that we know what a polynomial is, just a bunch of terms being added and subtracted together, okay, a single term could also be a polynomial as well, but usually it's when we have more than 1 term separated by pluses and minuses. Let's now talk about kind of similar to what we just did at the top of the page. Let's do it again. First of all, what are the terms in this polynomial? The first term there, as you can see, is 12x to the 4th y. Let's write that down. I'm just doing what they asked me to do here, list the terms. Okay. The second term is not 5, it's negative 5. Because officially, I do say that terms that, pardon me, I do say, and I just said this, that a polynomial is a bunch of terms being added and subtracted together. That's kind of the easy way of saying it. But in reality, the official definition of a polynomial is a bunch of terms being added together, just added. And so, as you guys know, when you have minus something, okay, as you've learned in the past, if you had, let's say, for example, you had 12 minus 5, you learned in, say, a pre-algebra class that that's the same thing as 12 plus negative 5. And so it's the same thing here, where if you have 12x to the 4th y minus 5x3y7, that's the same thing as plus negative 5x3y7. Minus 5, same thing as plus negative 5. And so that's why that's going to, because of the fact that the terms are the things that are being added together, it's going to actually be negative 5 is officially the second term. Negative 5x3y7, not 5. Okay. You do not have to write down plus negative 5 right here. You don't need to change this or anything like that, just as long as you know that it's the same thing as plus negative 5x3y7. As long as you know that by looking at it, that's what's important. Same thing here, minus x squared. Now remember, there's an invisible coefficient right here. When the coefficient is invisible, let's write it down first. That's going to be negative x squared. And we have to include the negative just like we did here. Okay, but that's an invisible 1 right there. When you have no visible coefficient, there's an invisible 1 right there. Okay, and so minus 1x squared. Again, you don't have to write the 1, but it is minus 1x squared. Minus 1x squared is the same thing as plus negative 1x squared. And so that's why the negative is included down here, okay? So plus negative 1x squared. So this is negative 1x squared. That's what's being added. Again, you don't have to write the 1, all right, but you know that this coefficient is negative 1. We'll write that down in just a minute. The last term there is 4, and that's just going to be 4. It's not going to be negative 4 because that's what's being added right here. We're not adding negative 4. We're just adding 4, and that's why this is just 4. Let's do those things that we did a few minutes ago at the top of the page. Let's list out the coefficients just to get some practice here, make sure we understand that. What are the coefficients of these 4 terms? This one is 12, as you can see there, the constant in front of the term. This one is negative 5, the constant number in front of the term that's being multiplied by the variable part of the term. We just mentioned that this coefficient is negative 1. Okay, now you do need to write it. If they ask you, see now if the coefficient is invisible but it's being multiplied by a variable, you don't have to write the 1 there, okay? It's implied that that's a negative 1 right there. And if the negative hadn't been here, then it would just be positive 1 would be the coefficient. But if you're just listing out the coefficient only and they're asking you, hey, what's the coefficient? Then you do need to write out the 1. You can't just write the negative sign. Okay, but when it's being multiplied by a variable, then the 1 can be invisible. And as we said at the top of the page, the 4, when there's no variable, the coefficient is just that whole thing, 4. Degrees. What are the degrees of these terms? Remember we said that when you have more than one variable, you add the exponents. Also remember that there's an invisible 1 right there. So 4 plus 1 is 5. 2 variables, so we add 3 plus 7. 3 plus 7 is 10, so the degree is 10. Here we have only 1 variable, so we just take the exponent, nothing to add there. We get 2. And as we said at the top of the page, when there's no variable, the degree is 0. So one more thing I wanted to mention that you will talk about sometimes. Sometimes they have what they call the degree of an entire polynomial. These numbers are the degrees of each individual term. But they also use the word degree to talk about the degree of an entire polynomial. Let's write that down. The degree of the polynomial. That's not the same thing because they're talking about the degree of the entire polynomial, this whole thing, as opposed to the degree of each individual term. The degree of the entire polynomial, all you have to do is look at the degrees of each individual term and pick the biggest number, which as you can see here is 10. Biggest number out of the 4 degrees that you have. So the degree of the polynomial is 10. Okay? They didn't ask that in the question, but I just wanted to write that down as an additional thing because we will talk about it sometimes in the future. Okay? So you have the degrees of the individual terms, and then if they ask for the degree of a polynomial, or if we talk about it, you know that that number is going to be the biggest of the degrees of each of the individual terms right here. Okay, so that is polynomials. Now, what we do sometimes with polynomials, let's take a look at an example up here. What we do oftentimes with polynomials, this is a polynomial right here. You'll notice that there's 5 terms here. And I know that there's 5 because it's separated by these 4 symbols right here, minus, plus, minus, plus. Again, we know that polynomials have terms that are separated by minuses and pluses. Okay, so there's 5 terms here, but the question is asking us what happens when we combine like terms. What are like terms? Like terms are terms that have the same variable part, not just the same variable. So x squared and x, those are not like terms. Not only does the letter need to be the same, x and x, but the exponent has to be as well. Okay, so x squared and x to the first, that's not like terms then because the exponents are different. However, x squared and x squared, now these two have the same variable part of the term, meaning they have the same letter and the same exponent that goes with that letter. And so combining like terms means what? It means to add. In some cases you subtract, it depends, but you either add or subtract the like terms when you combine like terms. We'll get into that here as we go along. So 3x squared plus 7x squared, what you do is you add the coefficients. If it's an addition situation, it is because it says 3 plus 7. Again, don't do the minus 4 here. We're just combining the like terms here. Okay, so we're just looking at these two right here. 3 plus 7. Okay. And so 3 plus 7 is 10. So what you do when you combine like terms is you take the 3 plus 7 equal to 10, but then the variable part of the term stays the same. It stays the same. Okay, this is different. We'll talk later about how to multiply and divide terms. That's totally different. But here we are adding, when we combine like terms, we are adding terms together. And we could also, in some cases, be subtracting, which I'll show you in a minute. But when you multiply and divide, that's different. Okay, the variable part of the term will not stay the same. But when you're adding and subtracting terms, you cannot add and subtract. This is really important because we'll do this a lot. When you're adding and subtracting terms, the variable part of the term has to be the same, which means that they're like terms. But then it stays the same in the answer down here. X squared and x squared, it stays as x squared. 3 plus 7 is 10. You put the 10 in front of it there, okay, with the 3 plus 7 right here. Let's keep going here. There's more like terms to combine. It said combine like terms. That means all like terms. So these two terms are like terms as well, right? Negative 4x and negative 8x. So let's read it here. Okay, we have x to the first and x to the first. So we know that those are both like terms. So what we do is we say negative 4, not 4, but negative 4. Remember that you got to take the entire term here, not just the 4, but the negative 4. Negative 4 minus 8. So this time we're subtracting. Negative 4 minus 8 is what? That is negative 12. Okay? And so notice the variable part of the term stayed the same for those two terms being combined. X to the first is still x to the first right here. Okay? And then finally, 5 does not have another term that's a like term with it, okay? In order for 5 to combine with anything, the only like term that would go with 5 would be another term that doesn't have a variable in it. If a term doesn't have a variable, the only like terms that would go with it would be terms that also don't have variables. Since this doesn't have a like term to go with it, to combine with, what you do is you just bring it down into the answer. Now let's talk about bringing stuff down into the answer for just a moment. Okay, when you when you combine like terms in a polynomial and you set up your answer, you write your answer, you have to have pluses and minuses in between your answers. Okay, it has to look like a polynomial still. All right, so the question is how do you know whether to put a plus or a minus in between each thing? Okay, here I put a minus, here I put a plus. All right. Now, if this had been negative, I would have put a negative in front of that. But when the first term is positive, you don't need to put a plus in front of it. Okay. So if the first term is positive, no plus needed in front. But if it was negative, we would have put a negative there. That's the first term. But what about the succeeding terms after the first term? You got to have minuses and pluses in between. As I said, the reason why I know that this one's a minus is because it was a negative answer. Okay, if it had been positive 12x, I would have said plus right there. Okay, it's different than the first term. The second term or any term after that has to have a plus even if it's positive. Okay, because that's negative, it's minus. And the reason why this was a plus was because it was positive 5. All right, and since nothing combined with it, it stayed as positive 5. So when you combine like terms, you got to have minuses and pluses in between each term. Okay? Now, so combining like terms is what you oftentimes do when you have just a polynomial. Okay, just a bunch of terms being added and subtracted. Another type of situation that you have, however, as you'll see down here in this problem, and some problems at the bottom of the sheet here, which I'll get to in a minute, is that notice that you have a polynomial in a bracket, a polynomial in another bracket over here with a minus sign in between, which means that you're subtracting the two brackets when it's written like that. Sometimes there'll be a plus in between the two brackets, as you see down here in this problem, for example. Two brackets with a plus in between the brackets. When you have two brackets with either a minus or a plus in between, okay, that means to either add the brackets if it's a plus, or in this case, case, if it's a minus in between the brackets, you subtract. You subtract the brackets. What does that mean, though, to subtract the brackets? It means this. It means, and we are eventually going to combine like terms, but there's something very important we have to do first. Okay, you have to change the minus in between the brackets to a plus. See how I did that right here? Okay, I just rewrote the problem over here. Okay, that's nothing new right there. Nothing new. But here I put the plus, minus here got replaced by the plus. And then the second polynomial, you change the signs of all of the terms in there, not just the first one. Okay, see what I did right here. I have negative 5, positive 7, minus 2. Negative, positive, negative. Notice how it changed from negative, positive, negative to positive, negative, positive. All three of them changed. Negative 5 is positive 5, positive 7 is negative 7, and negative 2 is positive 2. So I did that, okay? And then once you have bracket plus bracket, if you have bracket plus bracket, okay, with no numbers or terms in front of the brackets, okay, you just have bracket plus bracket, then you can combine like terms, even though the brackets are there. This is just when you have if you have brackets, you shouldn't combine like terms right away unless it's just bracket plus bracket with nothing in front of the terms, or I'm sorry, nothing in front of the brackets, okay, just bracket plus bracket. Okay, so I'm going to combine like terms right here, and you can see here that if I combine these, 3 plus 5 is 8, the x squared stays the same. Negative 4 minus 7 is negative 11. Okay, the x part stays the same. And then 6 and 2, 6 plus 2 is 8, and since that's positive, I put a plus there. Again, you don't need a positive, you don't need to put a plus in front of the 8 when it's the first term and it's positive. If it's the first term and it's positive, like I said, you don't need to put a plus in front. Okay. All right, so now sometimes they start you off with bracket plus bracket. You don't have a minus that you got to change to a plus. You just start off with that. When you start off with bracket plus bracket, nothing else outside the brackets other than that plus in between, you just start combining like terms right away. That's all you got to do. 10 plus negative 16, or 10 minus 16, same thing, is going to be negative 6. Okay? But the variable part stays the same, x4, y2. Okay, just like we've been doing when we combine like terms. Variable part stays the same. Here we have two terms that are like terms as well. Okay, and we have negative 3 minus 4. Negative 3 minus 4 is negative 7. Okay, and then the variable, oh, I'm sorry, I made a mistake right there. My apologies. Okay, I apologize if I confused you there. Okay, those are not like terms. Okay, we got to be careful there, just like I need to be careful. All right, so those are not like terms. Notice, in fact, that those two terms right there do not have any like terms that go with it. Okay, x squared, y squared, there's not another x squared, y squared term here. There's also not an x squared, y to the first term here. So like we said, when you have a term that does not have a like term that goes with it, you just bring it down into the answer, and because it's negative, we're going to put a minus in front of it. Okay, because again, we got to have the pluses or minuses in between in our answer when we combine like terms. Same thing here. You might be wondering, do I got to bring these down now, or can I bring them down later? You can bring them down later, but usually, as you'll find out as we go along here, talking about polynomials, usually we put the terms in order of highest degree to lowest degree. I'm not saying that that always happens, but it usually happens, so it's a good idea to just kind of get into the habit of doing that right now. Okay, so notice that this is degree 6, this is degree 4, and this is degree 3 because 2 plus 1 is 3. Okay, so that's what I'm kind of doing. Okay, again, not saying it's required right now, but it's just good practice to do that. And there's nothing wrong with it, okay, to combine those, okay? Or I'm sorry, to put it in the order of highest degree to lowest degree. So I did these two. I did these two. And so all I have left are these two right here, and they are like terms. Okay, and remember, there's an invisible 1 right there when you don't see a number in front of the variable. So this is 2 minus 1, which as you know is 1. Now remember, that's positive 1. Since it's positive 1, we're going to bring down a plus right here because it's positive. And the 1, you could write it if you want to. Okay, it's never wrong to write a 1 if the coefficient is 1. Okay, it's just that you don't have to. So I could bring down the 1 with the and keep the xy part the same. Or if I don't feel like writing the 1 right here, I can also erase it. Okay, it's your choice. Okay, so I'll just say xy because we usually don't write the 1, but again, don't feel like you can't. It's okay. So that's the final answer right there, because when you have bracket plus bracket, all you got to do is combine like terms, and that's exactly what we did. Okay. So now in this problem here, let's do the same thing. But before we do that, remember when you have bracket minus bracket, you have to change just the second bracket. Do not change the first bracket, you guys. Just the second one. All right. So notice that I'm rewriting the first bracket right here. I am not changing it at all. The minus in between the brackets stays, it changes to plus, just like we saw in that example up above. And then here we have what? We have minus, plus, minus, negative, positive, negative. And so that's going to change to what? That's going to change to positive. And remember, you don't need to write a plus. It's the same thing when you're inside of a bracket. If the first term is positive, you don't need to put a plus in front of that 16. This plus needs to stay there because it's outside the bracket. But inside the bracket, we're changing the polynomial signs. And so if the first term inside the bracket is positive, you don't need to put a plus. Okay. So positive, negative, positive. And you still got to write the minuses and pluses in between, okay, because this is still a polynomial, and polynomials need to have minuses and pluses in between. Okay. So now what you do is you combine like terms, because now that it's a bracket plus bracket problem, just like we learned up here, that's what you have to do when it becomes a bracket plus bracket problem. Okay, so combining like terms, you can see that this term doesn't have a like term partner here. Okay, there's no x5, y4 besides this one. So since that's a highest degree term, I'm just going to bring that one down first. Okay. And then notice that these two terms are like terms. Negative 5 plus 16. Remember, this is plus, not because of this plus out here. Because if this had been negative 16 on the inside, that would be minus 16. Okay, this plus right here is just telling us that we're in the bracket plus bracket situation, which is when you combine like terms. Okay, because that's positive, that means that we're going to add. Okay, so if that first term is positive and you don't see a plus in front of it, that means you're going to add 16 because it's positive. So negative 5 plus 16 is 11. And since that's positive 11, we're going to say plus 11. To fulfill our requirement of having pluses and minuses in between. Okay, like that. X3, Y2 stays the same. Then these two terms right here, okay, 2xy squared and negative 2xy squared. 2 minus 2 is 0. Oh, that's interesting. What do we do about that? Well, this is a situation where like terms sometimes cancel. Okay, because here's the thing, and you don't have to write this down. In fact, please don't. Okay, so officially what we end up with here is 0xy squared. But 0 times anything, you guys, is 0, isn't it? And so essentially what I would be doing here is I'd be writing plus 0. Or you could write minus 0, because that's the same thing, plus 0, minus 0. Okay, and so so what we'd be doing is we'd either be adding or subtracting 0, but that doesn't change anything, okay? Whenever you add or subtract 0 to something, it doesn't change it at all. So why write it if it's not going to change anything? So here's my thing that I'm trying to tell you here. If you have two terms that combine together to be 0, Okay, it just means that they cancel out because you don't need to write that answer. Okay, and so that leaves me with what, and so you don't need to write that. Okay, you don't need to bring that down. In fact, please don't. Okay, it's just extra stuff to write. We don't want to do that. And then the plus 7xy, that doesn't have anything to combine with it, so we just bring that down like we've done on other problems here in this worksheet. And there we go. Okay. What I'd like you guys to do right now is please try these bottom two problems yourself. Turn off the video, try it, and then I'll show you the answers for those in just a moment here. Let's see how you do. Okay. There we go. Sorry about that. So, let's take a look at number 1 right here. 8x squared and 5x squared. Notice again that this is bracket plus bracket, so you can start combining like terms right away. Okay, so 8x squared and 13, or pardon me, I just gave away the answer there, excuse me. 5x squared, those two together are equal to 13x squared. Okay, then we combine what? Then we combine the negative 6 and the negative, or pardon me, positive 2. Negative 6 plus 2 is negative 4. So we bring that down, and that's all you got to do right there. You just have to combine like terms when you have bracket plus bracket situation. Okay, so that's number 1. Number 2, take a look at that. What do we got to do first when you have bracket minus bracket, you guys? We have to change the minus to a plus, but we got to change the signs of all 4 of these terms right here. Do not change the first bracket, just the terms in the second one. So I did that right here. So look at what we did. Positive 3 and then negative, positive, negative. Positive, negative, positive, negative becomes negative, positive, negative, positive. Okay, so this becomes negative 3 right here. So we are going to be subtracting here because these two are what? They are like terms. 5 minus 3 is 2. Okay, and then the variable part stays the same. Then we combine what? Then we combine these two terms right here, because they're like terms. 6 plus 5 is 11, and so you get that right there. Okay. Then you'll notice that, and you might be wondering, hey, wait a minute, y to the first and x to the first, they both have the same degree. Which one should I put first? When they both have the same degree, it really doesn't matter which one you put first. Okay, if you're trying to, even if you're trying to put it into descending order of degree from highest degree to lowest degree, which is what we're doing here, it really doesn't matter. So I'm going to go ahead and do the 7y, the 7y and the 6y. Negative 7 plus 6 is negative 1y. Oh, excuse me, I wrote this down earlier, and so I went ahead and did the 8x first. Okay, again, like I said, it doesn't matter. So you see how I have negative 1y, which is the same thing as negative y. You can bring down the negative 8x first. Okay, again, like I said, it doesn't matter. Since negative 8x does not have another term that is a like term with it, I just brought that down, and then I brought down the negative y after that. Okay, so if you had said minus y first and then minus 8x behind that, that's perfectly fine. Okay, it's the same answer. They're both correct, whether you write it this way or if you write it negative y minus 8x here on the end of the problem. Okay, so that is adding and subtracting polynomials, bracket plus bracket and bracket minus bracket. So that concludes this, particular video on adding and subtracting terms and polynomials.